In this section, we'll be talking about linear modeling, using linear equations to model a specific real-world scenario. We're going to rely a lot on technology to generate results for us, but it will be up to us to think through the problem and pull the information out to know what to ask that technology to generate for us. To start this process off, we'll just look at how we construct linear models in general. If we're constructing linear models in slope-intercept form, meaning we're going to generate an equation of the form y equals mx plus b, then that equation has both a fixed term and a variable term, or component. So our fixed term is that constant added at the end. Our variable term is our slope multiplied by x. Because what will happen is that this constant term never changes, but our variable term, the value of that term, changes depending on our value for x. X can represent a wide array of values, something like time, production level. So as time passes, as our production level changes, as our price point changes, the value of that variable term will change. But if we think of things in terms of the variable term and the fixed term, I think that helps with setting up these equations. For instance, in example 1, we have a company's sales have been growing linearly. In January, monthly sales totaled $23,000, and the total has been growing by $754 each month. Depending on when you're watching this video, it might be January, it might not be, but let's pretend we're somewhere mid-year, so we know something about how sales have been going, and eventually what we're going to be doing in part B is projecting sales out into the future. In part A, we want to find an equation that represents total sales in months M after January. So total sales, S, would be generated from a linear equation. We know that because we're told that sales are growing linearly. We need to identify a fixed value and a variable value. Our fixed value is our base number. So back in January, that's the information we're given, is that sales were $23,000. The variable component to this is that sales are growing by $754 per month. The equation that we've got here makes sense because if we plugged in 0, which is our initial our initial month, we would get total sales equals $23,000, which is what they were in January. So we have our equation, and now in part B, we can find the total monthly sales in December of the same year. We need to think a little bit critically here. So what we're going to do is plug in a value for M. December is the 12th month of the year, but it's not a value of 12 because January was our zero month. So what we need to do is take 12 minus 1 to get 11. December is going to be the 11th month of the year if we consider January to be the 0 month. So for S, this will be set equal to 23,000 plus 754 times 11 because we want total sales 11 months after January. We can use a calculator to evaluate this, or we can use Wolfram Alpha. Using Wolfram Alpha is pretty straightforward. We just type in the expression that we want to evaluate. 23,000 plus 754 times 11. Click equals, and we get a value of 31,294. That's in dollars since this is total sales. And something to keep in mind for this class, money will always have 2 decimal places. Even if that comes out to an even number, rounds to an even number, we want to be clear. So our answer is that total sales will be $31,294 for the month of December. In example 2, we have a product that has a fixed cost of $3,600.24 and a variable cost of $10.53. Assume that the relationship between production level and cost is linear, so we know we'll have something in that slope-intercept form. We want to find an equation for the total cost of producing X items. So we're told that we have a fixed cost. That's whatever it costs to set up the equipment, whatever we have to pay to create this product. And then we have a variable cost. So that's materials that go into each product, salary we have to pay out to employees, whatever that variable cost is per item. So we have to pay that fixed cost plus a specific amount per item we actually produce. That's our fixed and our variable cost, and we have that cost equation. And now we can use it to find the total cost of producing 487 items. So we plug in 487 into that cost equation that we generated, and we end up with a result of $8,728.35 as the total cost to produce those 487 units.